Hi everyone, myself Kavya from Sri Venkateshwara College of Engineering. So today I am here to discuss a topic called solar cell in renewable energy resources. Here we are going to discuss a few topics related to solar cell. So first of all, its introduction and then whatever the materials used in solar cell and the construction and working of solar cell and types of solar cells and their advantages and disadvantages, and last their applications. So everyone knows, I'm sure everyone knows what does the solar cell means. First of all, what is solar mean? So since from our school days we have a little knowledge about the solars. So what is solar cell? I'll give you a clear, simple definition. Everyone knows sunlight, right? Everyone knows sunlight. From sunlight, what do we get? We get the rays. So when these rays falls on the solar, these rays will be absorbed by solars, and these sunlight rays will be converted into the electricity. That electricity we'll be using for our essential needs. So, in a simple way, a solar cell is defined as a cell which directly converts the light coming from the sun into electrical energy. In a typical way, like in a definition manner, how it can be defined? A photovoltaic cell, commonly called a solar cell, is a non-mechanical device that converts sunlight directly into electricity. And moreover, some photovoltaic cells can convert artificial light into electricity. Sunlight is composed of photons or particles of solar energy. That's what the solar cell defines. Means whatever the rays that are coming, it converts into electricity, and these electricities will be using for our essential needs, like uh, you know uh, for solar heaters, solar water heaters. For such general purposes we will be using this. And what are the materials used in solar cell? Crystalline silicon, zinc sulfide, cadmium telluride, copper indium, and indium phosphate. Construction of solar cell. So generally there will be two type of layers. One is N-type semiconductor and the other thing is P-type semiconductor. Based on these conductor, the solar cell construction has been defined. To explain in a simple way, as you can see here in the figure, it looks like a sandwich. How a sandwich is made up of? There will be a upper top, lower top, and middle will be something to it. Okay, it will be covered with two layers sandwich. In the same manner, the construction of solar cell also made up of two layers. One is N-type semiconductor and then the P-type semiconductor, and these looks generally like a sandwich. So I'll explain you the construction of solar cell. Mainly solar cell is constructed using the crystalline silicon that consists of N-type semiconductor. This is the first upper part of layer, also known as emitter layer. The top part of the solar cell, which is known as N-type semiconductor, and this is also known as first layer, also known as emitter layer. The second layer, which is base layer, it is known as p-type semiconductor, and both the layers are sandwiched, and hence there is formation of p-n junction between them. The surface is coated with anti-reflection coating to avoid the loss of instant light due to reflection. This is how the solar construction has been made, and now we will see the working of solar cell. As soon as the solar cell is exposed to sunlight, the solar cell which is present in the form of light photons is absorbed by semiconductor material. Due to this absorbed energy, the phenomena of photovoltaic occurs and electrons are liberated and produce the external DC current. The DC current is converted into 240 volt AC current using an inverter for different applications. And photovoltaic cells are made of special materials called semiconductors such as silicon. An atom of silicon has 14 electrons arranged in 3 different shells. The outer shell has 4 electrons, therefore a silicon atom will always look for ways to fill up its last shell. And to do this, it will share electrons with 4 nearby atoms. And now we'll look at the types of solar cell. There are basically 3 types of solar cells: monocrystalline silicon cells, polycrystalline silicon cells, amorphous silicon cells. So first let us discuss about monocrystalline silicon cells. Generally, the monocrystalline silicon cells are the cells which usually referred to as silicon cells. As the name implies, the entire volume of the cell is a single crystal of silicon. It is the type of cells whose commercial use is more widespread nowadays. And the polycrystalline silicon cells is a high purity silicons used as the base material in solar cells. It is made by a chemical purification process for metallurgical grade silicon. The polycrystalline structure results from molten silicon in which flat thin films has been drawn. And the amorphous silicon is the non-crystalline form of silicon used for solar cells and thin film transistors in LCD. And there are few advantages of solar cell. It is clean, non-polluting, renewable energy. Solar cells do not produce noise and they are totally silent. Maintenance cost is less, long lifetime, no fuel cost. And the disadvantages are cannot be obtained at night time because there will be no sunlight during night time, right? So solar cells are very expensive. Energy has to stored in batteries. Air pollution and weather can affect the production of electricity. Large area of land is required to produce more efficient power supply. And the applications are solar pumps, domestic power supply, telecommunication systems, electric power generation in space, ocean navigation aids. These are the applications of solar cells. Thanks for watching.